Okay, so we were doing October, November 21, paper 1-1, and we have completed till question number 10. Now we have question number 11. Okay. The diagram shows the Boltzmann distribution of energy for a reactant gas for a particular reaction. The activation energy is X. Okay. Which change to the diagram occurs if an effective catalyst added to the same temperature? We know catalyst doesn't change the shape of the effect. What would happen that X is the activation energy right now, which will become lower by adding the catalyst. So this will be the activation energy catalyst, right? So more particle will possess a higher value of E. No, the particle's energy doesn't increase. So your A statement is wrong. The peak will move to the left. No, it is wrong. There is no change in the peak. The peak will move to the right. So this is also wrong. It means we have left with the last part, last option D, and it will be correct. The value of the activation energy decreases. Yes, that's what happened as active energy is on x-axis. So it moves to the left, which means it decreases. So D is our correct answer. Is this understandable to everyone? Now, question number 12.
एक्सप्लेन कर सकते हैं इसका मतलब क्या है?
Which one?
Statement A.
They are saying more particles will possess higher value of E. E is what? If you see, it is the energy which is on x-axis. If they are saying that more particles will possess a higher energy of E, so it means that this would be the higher energy of E. Any position over here on the right of the graph, right?
जी sir.
So the molecules, the curve is not shifting to the right. Curve stays same on adding the catalyst. So there are no more molecules which have a higher energy of E, which have a higher value of E. It remains the same, right?
Yes, sir.
So that's why A is wrong. Now question number 12. Which element requires the least number of moles of oxygen for the complete combustion of 1 mole of its atom? Okay, they are asking which element requires least number of moles of oxygen for 1 mole of its atom. So if you write the combustion equation for the aluminium, it would be Al2O3, which means that if I have a 1 mole of aluminium over here, so I have to make it half. If I will make it half, it would become 3/2, which means 1.5 oxygen. So here I will put 1.5/2 to make it 1.5. So in this case, I can say that with 1 mole of oxygen, 1 mole of aluminium, I need 1.5 moles of oxygen. Now in the second case, there is a magnesium. When magnesium reacts with oxygen, what we will get? MgO. If I balance the equation, I have to put half before O, which means that for 1 mole of magnesium, I need half mole of oxygen, or you can say 0.5 moles of oxygen, right? So magnesium needs less number of moles as compared to aluminium. So A option goes wrong. Now, next case is phosphorus. Okay, so for phosphorus, when phosphorus reacts with oxygen, we would get, we know it's P4O10. So if I would balance the equation, I would put 4 over here and I would put 5 over here, right? So if I simplify it, so can anybody divide 5 divide with 4 and tell me the please? Yes. Can anyone divide 5 over 4? 5 divided by 4 and tell me the answer, please.
1.25.
Are you sure is it 1.25?
No, sir. 0.8.
0.8. 5 over 4 is 0.8.
सर 5/4 1.25 है जो मैंने पहले बोला, फिर आप 4.5 4/5 कह रहे थे जो 0.8 है, 5/4 1.25 है।
It's 5. It's 5 over 4. Okay, 1.25. So
जी
see,
सर।
for 1 mole of phosphorus, we need 1.25 moles of oxygen, which is still more moles of oxygen as compared with 1 mole of magnesium. So C goes wrong. Now we have a sodium. And if I balance the equation with sodium, when sodium reacts with oxygen, it will form Na2O, right? To balance the equation, I have to put a half over here because I have to keep, for example, 1 mole. So there is a half mole of oxygen atom, and here we have an oxygen molecule, so it would become 1 over 4. So when I compare oxygen, sodium and oxygen, I can say for 1 mole of sodium, 0.25 moles of oxygen is needed, which makes D wrong as well, and your correct answer is D. Is this understandable to everyone? Yes, is it clear? Now, question number 13. An element Y reacts according to the following sequence. Okay, Y burns in oxygen, so there is a oxide of Y, which is white solid. Then there is a chloride of Y, and it is a water soluble. And when adding sodium hydroxide, its hydroxide would form, which forms a white precipitate. And excess of sodium hydroxide, that white precipitate dissolves, right? So which element it can be? I think you can easily predict from these. So remember, all group 1 compounds are water soluble, right? So the white precipitates are not of sodium, so A goes wrong. And any non-metal oxide is an acidic oxide mostly, and that acidic oxide doesn't shows precipitate with an alkali on adding sodium hydroxide, so D goes wrong as well. Now you are left with magnesium and aluminium. So if you recall, for the test of aluminium ions, that when there is a aluminium ions in the solution and we add sodium hydroxide, white precipitate will form, and on adding excess sodium hydroxide, these white precipitate gets dissolved. So B also goes wrong, and your correct answer is C. Is this clear to everyone? Now, question number 14. in which list all are all three compounds soluble in water. Okay. Calcium carbonate. If you recall, group 2 carbonates are water insoluble. So it is not soluble in water. So A goes wrong. Calcium carbonate, again group 2 carbonates which are normally insoluble in water. So B goes wrong. Barium chloride is water soluble, barium hydroxide is water soluble, and the group 2 sulfate solubility increases down, decreases down the group, which is magnesium sulfate must be soluble. So C can be an answer. If you look at D, barium sulfate, down the group 2, sulfate solubility decreases, so it is not soluble. So D goes wrong as well. So it means your correct answer is C. Is this clear? For this, you have to memorize the solubility rules and the solubilities, and that's what I have shared in the slave in the notes as well. Now, question number 15. Anhydrous magnesium nitrate decomposes when heated, giving a white solid and a mixture of two gases X and Y. If you recall the equation, magnesium nitrate on heating gives you magnesium oxide, a solid, and nitrogen dioxide. There are 2 moles of nitrogen dioxide gas and half mole of oxygen, right? Okay. They have told you that Y is oxygen. Okay. What is the mass ratio of mass of X released over mass of Y released? Okay. So if you look at the equations, if you look at the balanced equation, you can easily identify that 2 moles of nitrogen dioxide is being formed, which means nitrogen is 14 and there are 2 oxygens 32. So 32 and 14 gives you 46 times 2, right? Is 2. There is oxygen, the MR of the oxygen molecule is 32 and it's half times 32, which makes it 16. So 46 times 2 gives you 92 is to 16. Okay. So if I have to make it 1, I have to divide it by 92 because this is what they called X and they have to take X as a 1 in all of the cases. And this is Y, right? So you have to divide this with 92 as well. So 1 is 2. Can anybody divide 16? 16 divided by 92 and tell me the answer, please.
0.174.
0.174, which makes it 1 over 0.174. So B, C, and D goes wrong, and A is your correct answer. Is this clear to everyone? Now, question number 16. In a series of 9 experiments to test the reactivity of halogens, an aqueous solution of each halogen is added to an equal volume of an aqueous solution containing halide ions as shown in the table. Okay. Halogen solution is chlorine. Halide solution in experiment 1 sodium chloride is added to a chlorine. So we can say that there is a no change because chlorine is there and chloride is there. If you recall their positions, there is chlorine, bromine, and iodine. So chlorine is above bromine and bromine is above iodine in the periodic table, right? So when I add chlorine in sodium bromide, I am just removing the spectator ion. So what would happen? That moles of chloride would form and bromine will form. Okay, so there must be a color change. Okay, so what would be a color change? A bromine brown or solution turns brown. Okay, but here there would be a no change. So in the same way, when chlorine is being added to sodium iodide, as iodine is below iodide, we will get 2 moles of chloride and iodine. Okay. Then in case of bromine, when we add bromine to sodium chloride, no change. Add to sodium bromide, here again no change. Okay. But here, when bromine is added to a solution containing iodide, bromine turns into bromide and iodine will form. Is this understandable to everyone? Now there is a iodine in experiment 7. No, we have just actually, Mahveen, we are just figuring out what is happening during the reaction when I add chlorine to a sodium chloride, when I add chlorine to a sodium bromide, and when I add chlorine to a sodium iodide. In the same way, bromine to sodium chloride, sodium bromide, and sodium iodide, and then I adding iodine to sodium chloride, sodium bromide, and sodium iodide. After that, we will read the next part, that what the examiner is asking. Okay. Initially, they have given you the information that we are performing these 9 experiments. So here, when I add iodine to chlorine, there is no change. On adding iodine to bromine, again, there is no change. No reaction would occur. In the same way, when adding iodine to sodium iodide, again, no change, because both iodine is and iodide are of both same element, right? Now, what they are saying, the 9 resulting mixtures are then shaken separately with an equal volume of hexane. If you recall, hexane is an organic substance. It's an organic solvent. The 9 tubes are left to stand so that the aqueous and organic solvent separates into a layer. How many test tubes contain a purple upper hexane layer? So remember this. There is a one important thing that you need to remember. If I ask you if there is a iodine in its aqueous state, what would be its color? Yes, can anybody tell me the color of iodine in its aqueous state? Yes, please. Yes, can anybody tell me the color of aqueous iodine? Remember, aqueous iodine is brown or red brown in color, but when iodine dissolves in any organic solvent, then you will observe a purple color. Okay, iodine is over here. Iodine is over here because there is no reaction taking place over here. Iodine stays as iodine over here in the experiment 8 as well, because there is no reaction taking place. And in the same way, in experiment number 9, as no reaction is taking place, so iodine stays as iodine. So when the 9 experiments are performed, after the performing the experiment, we have a 9 experiments in which there is a iodine. So if, oh sorry, there are 5 experiments which contains iodine molecules in the reaction mixture. So when we add a hexane in them, and when we shake it, when the iodine gets dissolved in hexane, the hexane turns into purple in each of the experiment where there is iodine. So how many experiments are there where there is iodine? Experiment 1, 2, 3, 4, and 5. So there are 5 experiments over here, which makes it A, B, and C all wrong, and D is your correct answer. Is this clear to everyone? Yes. In which part, Mehveen? In which experiment you are talking about? Because bromine is less reactive than the chlorine. See the position of bromine. Bromine is below chlorine. So bromine cannot displaces the halide, the chloride ion. Remember the halogen which is above in the periodic table can displaces the halide, can displaces the anion of the halogen which is below it in the periodic table. So that's why chlorine can change, can displaces bromide and iodide, but bromine cannot displace chloride, but only displaces iodide, and iodide cannot displace chloride and bromide. Okay. Now, question number 17. Z is a compound of sodium, chlorine, and oxygen. 45%, 45.1%. It contains 45.1% by mass of oxygen. Z is prepared by reacting sodium hydroxide with chlorine. Which row shows the conditions which is used for the reaction and the oxidation state of chlorine in Z? Okay. So, if you recall, they are saying that the Z is a compound containing 3 elements: sodium, chlorine, and oxygen. So when when chlorine reacts with the sodium hydroxide, if it's a cold dilute sodium hydroxide, then we will get NaClO. And if it's a hot concentrated sodium hydroxide, then we will get NaClO3. Right? So we have to figure out of these two compounds, which compound have a 45.1% oxygen. So look at over here. In this compound, there are 3 oxygen. So 3 times 16, which makes it 48. If I have to find the percentage of oxygen, so 48 over 23.1 plus 35.5 plus 48 times 100. So can anybody tell me the answer? If I'm getting 45.1% over here, then it means this would be the compound Z. If I'm not getting the 45.1%, then this compound would be the compound Z. Yes, can anybody find the percentage of oxygen over here?
Yes, sir, it's 45%.
Okay, if it's 45%, which means that this is our compound Z. So if this is our compound Z, so this compound is made from hot concentrated sodium hydroxide. So these two conditions are wrong. Now, if you look at in this compound NaClO3, if you will work for the oxidation state, so the net charge is 0. Oxygen have a -2 times 3, which makes it -6. Sodium is +1, which clearly indicates that chlorine is +5 over here. So this +1 makes C wrong, and your correct answer is D over here. Yes, is this clear to everyone? Now, question number 18.
Tough crowd. How about another one?
Okay. Which row is correct? Ammonia molecule. If you recall the shape of ammonia molecule, it is pyramidal. D is the correct answer. Okay, so it's a pyramidal. So from the first column, we can easily figure out that our C and D options are wrong. If you look at the ammonium ion have this shape, which is tetrahedral. Now, if we look at ammonia molecule, there are all sigma bonds, right? If you look at ammonium ions, again, there are sigma bonds. So B goes wrong, as they said that ammonium ion have a pi bond. There are all single bonds in ammonium ion as well. So A is your correct answer. Okay. Now question number 19. The table describes two possible environmental consequences of adding too much ammonium nitrate fertilizer to soil. Okay, this is basically related to eutrophication because of a nitrate ion. Remember, nitrate ions and phosphate ions are, responsible for eutrophication. So when there are more nitrates or fertilizers in the soil and when they leaches out to nearby water reservoir, due to which there is a increased growth in plants in rivers, which makes A and C wrong. And remember, eutrophication doesn't causes any, photochemical smoke. So D goes wrong as well, and B is the correct answer. And remember, now eutrophication is not the part of the syllabus anymore. Okay. Now question number 20. Now from 20 onwards to question number 30, you will find all the organics. X2-ene can be made by reaction shown. Okay. If you see the mechanism, which statement about this reaction is correct? Okay. So This is this ion over here is behaving as a Bronsted Lowry base. Is this statement is correct or wrong? What is a Bronsted Lowry base? If you recall the Bronsted Lowry base, which a base Bronsted Lowry base is defined as which is a H positive ion acceptor. Acid is a proton donor and base is a H positive ion acceptor. So if you see over here, now it contains the H in it. So it means that it is accepting the H positive ion, right? Which makes A statement correct. Now, if you see, they are saying that this ion is behaving as an oxidizing agent. No, because uh, it is a there is a no change in the oxidation state of this carbon over here. The carbon iodine bonds break via homolytic fission. We are observing the whole head arrow. So it goes wrong because it's a heterolytic fission, not homolytic fission. This is a hydrolysis reaction. No, in hydrolysis reaction, either alkali, acid, or water is involved, not any alcohol is involved. So D also goes wrong. So B, C, and D are the wrong ones. And A is your correct answer because it is accepting the H positive ion. Okay. Now question number 21. Structural isomers only should be considered when answering this question. Okay. Molecule X contains 3 carbon-carbon double bonds. 1 mole of X is reacted with 3 moles of HBr. The carbon skeleton is unchanged. How many different products are formed? Okay. So what would be the possibility of the different products? Let's have a look. Let me draw the first possibility first. Then we will look into the rest of the ones. So one scenario can be that we know we are adding HBr. So H is added over here and bromine is added over here. In the same way, the H is added over here and the bromine is added over here. And H is added over here and bromine is added over here. Okay. So that can be the first possibility. What can be the other possibility? That this position remains same, but here bromine attaches to over here and hydrogen is added over here, but here it remains unchanged. Okay. What can be the next possibility? That this hydrogen is added over here and bromine is added over here. And here the bromine is added on that carbon. So here we got 3 possibilities. Uh, what can be any other possibility? This is carbon. So here it appears to be three possibilities only, which means that B, C, and D goes wrong, and A is your correct answer. Okay. For exam point of view, I will always suggest if you find this kind of a question where you have to draw and check the number of possibilities of the isomer, do leave that question for the last. Do not attempt it because it will consume time on one question because you have a 40 questions to attempt in 1 hour 15 minutes. Do the rest of the questions, and if at the end you will get a time, then try to attempt this kind of a question where you have to draw the isomers. Okay. To structural isomerism and stereoisomerism should be considered when answering this question. Okay, here you have to consider both structural and stereoisomerism. A colorless liquid having C5H11Cl exists as a mixture of two optical isomers. Okay. When heated with sodium hydroxide in ethanol, a mixture of only two alkenes is formed. What could be the colorless liquid be? Okay. So if it exists as a mixture of two optical isomers, which means that it must have a chiral center, right? And when it undergo elimination reaction, as they have provided you information over here, then you will get the only two alkenes. So if you look at the first one, this carbon, let me draw this one, a carbon having a hydrogen, a chlorine, and C2H5 on both the sides, which makes it that there is no chiral center in this A molecule. So if there is no chiral center, so A goes wrong. Now, if you look at B, B have a this carbon chiral center. Let me draw 1, 2, 3, 4, and 5. There is a chlorine. Okay. There is a chiral center. Now, if it will go under elimination, you will get a double bond over here, or you will get a double bond over here. If there is a double isomer, but there is a possibility that beside this trans isomer, a cis isomer would form. So instead of two alkenes, we are getting three alkenes over here, which makes B wrong as well. Now, in case of C, there is 1, 2, 3 carbons. Third carbon have a chlorine and two CH3 groups. Okay. So if it this would undergo elimination, there is a one possibility. This alkene. And there is a other possibility. This alkene. But there is one more thing. Again, there is no chiral center over here. I initially overlooked, sorry. No chiral center. So there would be no optical isomers. So C goes wrong as well. If C goes wrong, B goes wrong, and A is also wrong, then D is your correct answer. If you look over here, there is 1, 2, 3, 4, and there is a chlorine over here. So this one is a chiral center, and one possibility is this the alkene over here, and the other possibility is alkene over here. So there is a chiral center, and we are getting two alkenes. That's why your D option is the correct option. Okay. Now, question number 23. When 2-bromo-2-methyl propane reacts with aqueous sodium hydroxide, an alcohol is formed. Which diagram describes the first step of the reaction mechanism? Okay. So, if you recall 2-methyl 2-bromopropane, so it's a propane, which means 3 carbon. On second carbon, there is a bromine, and on the second carbon, there is a methyl. So here there is a CH3, here there is a CH3, here there is a CH3. So if you recall, you can look at this structure, you will easily find that it's a tertiary one. And if you remember, tertiary undergoes SN1 mechanism where the carbocation is formed initially. And when the carbocation is formed, then the nucleophile will attack, right? So it makes C and D wrongs because nucleophile is attacking initially. So nucleophile will not attack until the carbocation of the tertiary structure will form. So only heterolytic bond breaking is take place, which is showing in A and B. But if you look at A, the direction of the arrow is wrong because arrow is always towards the head of arrow always points towards the more electronegative element, because whenever the bond is broken down, the element having a which is actually more electronegative would took the pair of electrons, or which took the bond pair with itself. So A goes wrong and B is your correct answer. So I hope is this clear to everyone. Question number 23. Now, question number 24. When an organic compound Q is treated with phosphorus pentachloride, PCl5, fumes of hydrogen chloride are evolved. When Q is warmed with acidified potassium dichromate, the solution turns green. Okay. What is Q? So if you remember the AS syllabus, you can easily recall that PCl5 actually reacts with alcohol. So when PCl5 reacts with any alcohol, I'm just writing the general equation. The OH is displaced by a chlorine. Along with that, we will observe PCl3 and HCl. And due to these HCls, there are fumes of hydrochloric acid. And further, if you recall this alcohol, and as they say that it turns green on dichromate, so that's what alcohol do. Alcohol undergo oxidation in the presence of a dichromate, and as a result, alcohol turns into carboxylic acid. So if you look at this one, there is an aldehyde, so A goes wrong. There is a carboxylic acid, so B goes wrong. These two both have an alcohol, but if I draw the structure of the D, see the carbon having an OH have 3 CH3 groups, which makes it CH3. Oh, sorry, which makes it tertiary. And if it's tertiary, it never oxidizes. Sahi hai? So it's tertiary. So it means that it do not oxidizes. So D goes wrong as well because the Q is undergoing oxidation because it turns the solution into green. So C is your correct answer. Is this clear to everyone? Now question number 25. Alcohol white gives a yellow precipitate with alkaline aqueous iodine. So From here, what I can conclude, if there is an alcohol Y and it is giving a yellow precipitate with alkaline aqueous iodine, so this alcohol must have this group in it, where there is the fourth bond of this second carbon have a hydrogen or an alkyl chain. It can be any one thing, either hydrogen or alkyl chain. It can be oxidized to give a mixture of our products, including substance Z. Okay. Substance that gives a red brown precipitate with Fehling solution. So it clearly indicates that if substance Z is giving a red brown precipitate with a Fehling solution, so it means Z can be an aldehyde. And if Z is an aldehyde, then it clearly indicates that this alcohol must be primary, because primary alcohol is going to give you an aldehyde. Okay. Is this understandable to everyone? Yes. Now, if you see in this structure, in these two structures, there is no primary alcohol. So C and D goes wrong. And if you look at B, there is a this C which have a OH, which is tertiary. And if it's a tertiary one, then you are going to get a single product only. So that's why B goes wrong. And your correct answer would be A, because here this turns into ketone and this turns into an aldehyde. So you are getting only a mixture of product over here. Now, question number 26. CH3, CH2, CO, CH2, CH3, it's a ketone. Reacts with hydrogen cyanide to form an organic product called cyanohydrin. So what would happen in this reaction? If you recall, I'm just drawing the product over here, that when it reacts with HCN, this C double bond O turns into C single bond O, and O is bonded to H, and that same carbon have a carbon nitrogen triple bond group nitrile. Then there is a CH2. Okay, 1 minute. There is a CH2, CH3. In the same way, there is a CH2, CH3. Okay. Which statement is correct? The cyanohydrin product has a one chiral center. Yes, do it have a one chiral center? So if you see both the sides have a same group, so no chiral center. A goes wrong. Cyanohydrin product is formed by the electrophilic addition. No, if you recall, it's not electrophilic addition. This reaction is considered as nucleophilic addition. So B goes wrong. Cyanohydrin product is formed via an intermediate. It contains COH bond. No, in an intermediate, there is an oxygen with a negative charge, not OH over there. The H is bonded to oxygen at the end of the reaction. So there would be no intermediate containing an OH group. So C goes wrong. It means D is correct answer. Here one chiral center, this have said is wrong. The formation of cyanohydrin product requires the use of a cyanide ion as a catalyst. Yes, because if you recall the conditions with HCN, we need NaCN or KCN as a catalyst. So D is the correct answer. Now question number 27. Reduction of a compound R with LiAlH4 gives the compound 4-methyl pentane 2,3 diol, what could be the identity of a compound R? So if I draw this one, pentane 1, 2, 3, 4, 5. So 2,3 diol, and here we have a methyl. Okay. So which compound can reduce to this one? So if you see the branch is on the second carbon, here the branch is on third carbon, so this goes wrong. Okay. And here the alcohols are on the second and the third carbon. The aldehyde on the first carbon makes D wrong. In the same way, the aldehyde on the first carbon in the B also makes it wrong. So A is the correct answer. There are two ketones, and both the ketones on reducing turn into two secondary alcohols contained by one molecule. Is this clear to everyone? Question number 27. Now, question number 28. Citric acid is found in lemon juice. Okay, this is the formula of citric acid. Which volume of 0.4 mole per dm cube sodium hydroxide solution is required to neutralize a solution of containing 0.05 moles of citric acid? Okay. So if you look at this, how many acids we have? 1, 2, 3. So it means one with 1 mole of sodium citric acid, 3 moles of sodium hydroxide would react. So we are provided with the concentration, and we have to find the volume, right? So we are given with the 0.005 moles of citric acid. So according to the equation, 1 mole of citric acid reacts with 3 moles of sodium hydroxide. So 0.0050 moles of citric acid would react with X mole. Can anybody solve and tell me the value of X? If I'm not wrong, it would be 0.015, right? So these are the moles. Now if I have to find the concentration, so concentration is equals to moles over V. So concentration is 0.40. I have to find the volume, sorry. The moles are 0.015, and here we got the volume. So volume is equals to 0.015 over 0.40. Can anybody tell me the answer of volume as well over here? Yes, please.
Zero point zero three seven five.
0.0375, which is decimeter cube. So when you convert into dm centimeter cube, you will get option C, 37.5. So that is my correct answer. Okay, now the last two questions. Question number 29. The structural formula of an ester. Okay, if I show you the structure, there is a C having a 2CH3 on it, and H, then O, then C double bond O, then CH2, then again CH2, and then CH3. This ester is boiled with aqueous hydrochloric acid, which two products are formed. Okay, it would be broken down from here. So one product that I'm going to get is this is a butanoic acid, right? So C and D goes wrong. Now the product, the alcohol that I would get over here is CH3, CH, CH3, OH. So if you look at its name would be, there are 3 carbon atoms. So propane 2 all. So propane 1 all makes A wrong and B is your correct answer. Okay. Now, question number 30. Okay. The infrared spectra of 3 organic compounds are shown. If you see this peak is of due to C double bond O only, this one, which makes it either aldehyde or ketone. If you see there is a C double bond O peak and then OH of COOH makes it a carboxylic acid. Then this one having a peak of OH from 3200 to 3600, which makes it alcohol. What could the 3 compounds be? Okay, so spectrum 1 is an of aldehyde or ketone. So D and A goes wrong due to these 2. So it can be propanol. Then spectrum 2 is of carboxylic acid. So here you go. Here it's written propane 2 also. C goes wrong. It means B is the correct answer. C, here we are getting acid and here we are getting alcohol. So section A is completed. Now section B is not the part of the syllabus anymore. Now you are not going to get the 10 questions in this manner. That's why we are skipping this. And tomorrow, hopefully, we will be going to start a new class paper. Okay. Okay. Then see you everyone tomorrow. Take care. Allah Hafiz.